Alright, welcome. I'm Dave and I work at DCOM Engineering. Today I'm going to talk about test-driven development, and we're going to talk really about the fundamentals of test-driven development. And I'm going to take you through the steps to implement TDD into a project of yours. And we're going to talk about the different types of tests, and we're really going to dive deep into the core of TDD in general. So for those of you who are probably wondering, I did recently rename my business from DCOM Productions to DCOM Engineering. So going forward, any videos and things like that will be referenced under DCOM Engineering. And of course, you can find my content at my blog, danderson.me, as well as this YouTube channel, youtube.com/user/DCOM-network, where I stream any screencast or presentation, anything that's video content I will put on this YouTube network. So before we get into anything, I want to focus mainly on the fundamentals of TDD. So as we go through this presentation and into the demo project and into the conclusion, I want you to focus around the fundamentals and the core principles of TDD rather than specific constructs. Because the fundamentals you will take with you for the rest of your career, for the rest of your job, whereas the specific constructs may vary depending on the framework you use, tools you use, programming languages, etc. So for our example though, we'll be using Visual Studio with C# and .NET and MS tests. So I want to point out that TDD does not replace other quality control methods. So if you do inspections or pair programming, checking your own code at your desk, manual testing, code reviews with your senior developers, TDD does not replace any of this material. TDD really, you should use it in conjunction with these other quality control methods. Studies have shown, especially at NASA, the Software Engineering Institute, studies have shown that doing only one of these quality control methods results in low defect detection, whereas doing multiple of these quality control methods in conjunction with one another results in very high defect detection rates. So definitely don't throw any of these out the door just because you start doing TDD. So if it doesn't really replace any of these specific quality control methods, what do you get from it? So primarily with test-driven development, the first major improvement you'll notice is that you'll spend a drastically reduced amount of time in the debugger. So you won't actually be stepping through code as much. You won't have to set breakpoints and go through your normal debugging routine nearly as much. So you should see your debugging time drastically be reduced. And of course, this will work over time because TDD takes some time to get into the groove. But in conjunction with reduced debugging time, you should also over time see increased quality in your projects because you're building on a foundation of high quality tested code versus building on untested code. So ideally your project quality should increase over time as well. And then of course, when you take these two things into consideration, new development time should also drastically reduce because you're building on, again, on top of a high quality foundation. So when we talk about test-driven development, there's actually all kinds of different types of tests. Most common kind of test you'll hear about is a unit test. And any test-driven development framework you use really evolved around the concept of a unit test. So if you use MS tests, again, they're going to be called unit tests. Same thing with in-unit. But there's also different kinds of tests in test-driven development that you'll use with unit tests. Or you will use unit tests to implement these other types of tests. So first and foremost, the definition of a unit test is that you're testing a single requirement in an isolated, well-defined scope. So generally, you're testing one thing, and any complex dependencies, you generally remove those. So you ideally want to be testing your unit tests in an isolated manner in memory. So complex dependencies such as network I/O, integrating with other types, those are generally mocked out and stubbed, and we'll talk about stubs and mocks later in the presentation. So a good way to remember what a unit test is does this do what it says it's supposed to do? Then we go into an integration test, which you will also implement through a unit test, but an integration test really tests the integration of two or more components coming together. So if developer A develops one class and developer B develops another class and they depend on one another, you want to make an integration test to make sure that the two interact correctly and have the desired behavior. This also includes different subsystems. So this includes network I/O, file I/O, complex dependencies. Integration tests are much harder to write than unit tests because oftentimes there's setup required, teardown required, maybe you need to inject some test data, and then maybe you need to reset the test data. So integration tests are a lot more time consuming and far more difficult to write. They're also far more difficult to keep clean. Again, the best way to remember what an integration test really is ask yourself, do these two things work together correctly? So when you have unit tests and integration tests, you also want to have regression tests. And regression tests really ensure that if a customer reports a defect in the software and you're assigned to fix that, you develop the fix, you want to also test to make sure that the fix is in fact correct, that the correctness of the fix has a high accuracy. But you also want to make sure that you didn't regress the software by introducing further defects. So that's kind of the gist of a regression test. So again, just a very simple way to remember is, did I regress the software by making this change? Smoke test, this predates back really far before software really was evolved, all the way back to, I believe, plumbing. So you could go read out there about smoke tests, and people have different explanations of when smoke tests first came about. But the one that I was able to find it dates all the way back to plumbing, where they would fill pipes with smoke to see if the pipe was leaky. And a smoke test is basically, does it work or not? So in software development, a smoke test is really just to see if something works in general, such as starting a service. Can I even connect to a web page, for example? So the best way to remember it, does it work at all? System tests, these are I believe, one of the most important tests. So once you're done with your software development, you're ready to deploy your software, you want to make sure that the execution of your software in its final configuration, meaning how it's going to be in production, works as expected. So again, very easy way to remember, does everything work as expected in production? And there's a lot more different types of tests as well. There's component tests. If you read Code Complete 2 or any other material like that, there are various other types of tests that you can have, but these are the most common ones when you're talking about test-driven development. So TDD really has 5 core steps to take, and you want to apply these steps very consistently as you're doing TDD. So step 1 is write the test before you write any code. So this changes your mindset from designing code to be consumed to consuming code to create the design. And what I mean is, oftentimes a developer will take a requirement and they'll develop a class, maybe a file class that wants to take in a file path that I expose as a property. Maybe I have some methods to read and write to the file. I might provide more methods than are necessary, which creates code bloat, or I might not provide enough methods, which means I didn't meet the requirements. Whereas test-driven development, you take your requirements and you write a test case for each that ensures that your requirement will be met. And what happens is, as you're writing your test, that kind of molds and exposes the design that you will implement in your code. So it changes that mindset backwards, and it works very well. After you write your test, you should verify that your test actually fails. So this helps you focus, again, on writing just enough code to make your test pass. So it helps you make sure that you are staying focused around the requirements. And then again, once your test fails and you verify that, you want to write just enough code to make your test pass. And once your test passes, you should definitely go back and verify your test and your implementation code just to make sure, because oftentimes as developers, sometimes we'll even write invalid tests. And then the final step, once you've done all the previous 4, is to polish your code to quality standards. So if your test doesn't pass, really you would just repeat steps 1 through 3. But by the time your test passes, you should go back and refactor and polish. So this takes us into our demo that we're going to dive into. We're going to build a very simple IOC container. It's going to facilitate type registration. So we're going to be able to register an interface to a type that has a default constructor, parameterless default constructor rather. So it's going to be a very basic IOC container. We're not going to do anything fancy or anything complex. If you don't know what IOC is, you'll want to do a little bit of research on inversion of control and dependency injection, so you at least understand on a high level what they are. And then what I will not be covering is mocks, stubs, any sort of TDD framework such as mock-Q, Rhino mock, anything like that. And we won't be covering integration tests. I want to focus on the core principles of TDD and just give you an introduction to test-driven development. So our demo is going to be very basic. We'll probably have actually about two to three tests. Okay, so let's dive right into our demo. So we'll be using Microsoft tests for this. So in my project, I have a C# class library, nothing special about that. And then I have a C# unit test. So in Visual Studio, I believe you have to have Visual Studio, I want to say Professional or later. It might be Visual Studio Premium or later, but it comes with the Microsoft testing tools. And what you'll want to do is add a unit test project to your solution. If you don't have access to Microsoft tests, you can use InUnit. It's a popular open source unit testing framework for .NET. You could translate everything that you learn from this demo very well over to InUnit because they're very similar. So what we want to start off by is actually adding a test class, and you'll see a couple different naming patterns out there. People will call their test classes. In our case, we want to test a IOC container, and some people will call it IOC container tests, and other people will call it fixture. And this is the naming pattern that we're going to use in this demo. So the first thing that we need to do is in Microsoft tests, we need to call it add the test class attribute, which is in Microsoft Visual Studio Test Tools Unit Testing. And we're going to add a test method. So based on the requirements for an IOC container, like I said, we want to be able to register a type that maps to another type that the IOC container can create. So we know that we're going to have a register method on our IOC container. And then we also want to be able to resolve a type. And we'll actually rename this register type. So again, the objective of TDD is start out with your test. So we're basically saying, how do I want to consume the code? So I'm going to say, I want to have a class called IOC container. Just a very simple parameterless constructor. And I want to just be able to say container.register. And I know that I want to register a type to another type. So I'm going to say I want to pass in a generic type parameter. So I'm going to say registerable type. And then I want to say that I want to be able to resolve it to a type. So I'm going to say resolvable, or resolved type rather. Now, most test-driven development frameworks come with a class called assert or something similar, and this is basically how you run your test conditions for your test. So basically what happens is they provide you a bunch of methods like is true, is false, is null, is not null. And you basically use these to tell the test framework how you want to test for a condition. So in this case, I want to say is true, and I want to say container. I need some way to tell me whether my registration has succeeded. Now I know I only registered one type, so I'm going to say registered types count is equal to 1. So by looking at this code, it tells us a few different things. First off, this doesn't compile, which is exactly what you want. Again, we're writing the test first. But looking at this code, it tells us kind of how we are going to design the class. So we can see that we're going to need to create a IOC container class. It needs to have a default constructor that takes 0 parameters. We need a register method that takes 2 generic type parameters. And then we need a property called register types that facilitates the ability to keep track of how many types are registered. So now that we've verified that this does not compile, so if I go build, should fail, and it does, we can start actually creating just enough code to make this test compile. So we're going to go to our library project, and we're actually going to start the actual implementation for our IOC container. And again, we know that we need a couple different things for this. So I'm going to move this over here real quick. I know that we need a register method that takes 2 generic type parameters. And I also know that we need a property called register types to keep track of our type information. So I'm going to call that. We're going to use a dictionary because we know we want to register a type to another type. And we know that we also need a default parameterless constructor. Okay, and we're going to, we'll just leave our register method empty for now. So let's close our IOC container implementation and take a look at our test. So our test, for the most part, would compile. We have almost everything we need. We have our class object, we have our register method, and we also have our register types property that facilitates our ability to count how many types we have registered. So 2 of the things that are required for this test is a interface that we can map to some type. Now, really, these don't need to have any sort of implementation. These are just testable objects. So we're going to create these in our test library. So I'm going to create this iRegisterable type interface. I don't care that it necessarily has any contracts defined on it. And I'm also going to create this resolved type class, and it's going to implement iRegisterable type. So now our test should actually compile. But if I run the test, let's see. For some reason my methods are not showing up. There we go. Okay. So this is good. Our resolve type test passes, but we don't have anything in that, so we're going to ignore that. But our register type test fails, and that's as expected. So it's basically saying assert is true, register types count equals 1. Well, we haven't actually implemented any code, but this is we're on the right track. So now that I know our test compiles but it fails, we can actually write just enough code to make the test pass. So to do that, we're going to go to our IOC container. And really this is very simple. I just need to say register types add, and we're going to say type of T1, type of T2. So we're using the type information of our generic T1 parameter as the key to the dictionary, and then the value of the dictionary will be the type that we want it to resolve to. So if we go back to our test now, we've only written 1 line of code. But if I rerun this test, we'll have to see what happens. Okay, so our test passes, and that's good. So now we've verified the behavior for our register method. So now we can go ahead and move on to some of the other functionalities, such as being able to resolve the type. So before we move too far forward though, we're going to refactor some of this stuff into their own files. You want to keep your unit tests as clean as you would normal production code. Okay, so now we're going to write our test for being able to resolve a type. So again, we're going to create an instance of our IOC container. We need to register a type. So we're going to reuse our same two test objects, but this time we're also going to say we're going to call our container's resolve method, which it actually doesn't have one yet. So we're going to say I want to resolve a instance of a registerable type. And then I want to check for two things. First, I want to check that our instance is not null. And then I also want to check that our instance is actually the type that we're trying to resolve. So I want to say equals type of resolved type. So this test checks for two things again. That it actually does resolve something, and that something is what was originally registered. So if we actually, this test does not compile, which is good, so now we can move on to writing just enough code for the test to pass. So I'm going to go ahead and create the resolve method on our type. It's going to take a generic type parameter. So really we're going to say equals, and we'll use a little bit of reflection. Say type of t, and we actually need to go ahead and do a typecast to t, and then we'll return our instance. So very tiny amount of code, but now we could go ahead and run our test and verify that the code we wrote is correct. And we can see that our test actually failed. So what this tells us is we did something wrong. So we actually get a exception saying that cannot create an instance of an interface. So if we look at our code, we can say that, well, we registered an interface, iRegisterable type, and we registered it to resolve type. And then what we're doing is we're saying I want to get an instance of iRegisterable type by resolving an iRegisterable type. So I don't see anything wrong with the test itself. So what we need to do is actually look into the code at this point. And I can see that we're trying to create a type of iResolvable type. We're going to return a iResolvable type, that's correct. But here's the problem. We're trying to create an instance of iResolvable type, and that's not what we want to do. What we actually want to do is create a instance of what was registered. So we're going to say registered types, and for the key, we're going to pass in our type of t. And that will return us whatever the generic type parameter was registered to. So let's go ahead and run our code. And now we can see that our test passes. So up until this point, we've done zero debugging, actually. We've verified all of the behavior and functionality by writing tests and reviewing code. But you can actually do debugging in unit tests if you want. So I could actually debug this test, and I could actually browse the information just like I was running in a test program. So you get all the benefits of the debugger in conjunction to unit testing. So before we move too far forward though, there's a couple things that we need to do. First off, one of the other fundamentals of test-driven development is to write as little code as possible. And we actually have some code duplication. And as a developer, it's our responsibility to, when we identify duplicate code, it's our responsibility to remove it. So the duplicate code that we really have is this IOC container instantiation. So what we can do is we can create a test initialize method. In other testing frameworks, they use the concept of a test setup. And we're going to say public void test setup. And we'll say private static C container. And in our test setup, we'll create a new instance of our IOC container. So what this does is it allows us to delete this line of code in each of our tests, because we can assume that as we write more tests, we'll need to reuse this container object. So it's a little bit silly to instantiate it in every test when we could just reuse a little bit of code. Okay, so some of the other things we need to do is actually write a few more tests. So now that we've written the two most basic tests, we are able to register a type and we're able to resolve a type. But what happens for all the other scenarios? Because we're writing this code to be consumed by other developers. So what happens if they try to do something that we don't expect them to do, such as register an abstract class? We should write a test for that. So we're going to write another test method, and we're going to say public void should not register abstract type, because you can't create an instance of an abstract type. So we're going to write our test, and we're going to say register. We're going to say iRegisterable type, but we're going to try and register it to a abstract type. And then we'll say, for this, we'll say that the behavior we want is that we want our register method to throw an invalid operation exception. So we'll say expected exception is type of invalid operation exception. So what this does is this says that when we call the register method, our test is expecting an exception to be thrown, and the type of exception should be invalid operation exception. So if we don't get an invalid operation exception, the test should fail. But if we do, the test should pass. So again, we need to create our abstract type. So this will be a simple abstract class. And again, this needs to implement iRegisterable type. And we'll move this to its own file. So if we run this test, we can see that it fails. And we can see that it did not throw an exception. So what we can say is we need to go change the code now to support our test case. So we actually want to say if, and to prevent code duplication, we'll say type equals type of T2. And in this case, we can actually pass our type in as a parameter when we register it. But here we want to say if type is abstract, throw new valid operation exception. And then we'll make a pretty useful message. Oops. We'll say cannot register a type because it is abstract. And then actually we need to do, I missed one thing. We'll say string.format, and then we'll say type. Okay. So let's do a little bit of code review here. When we call our register method, we're going to get the type information for type of our second generic type parameter. And we're going to check if the type is abstract. If it is abstract, we're going to say, no, we can't do that. And we're going to throw an invalid operation exception. And we're going to provide a useful error message. So it cannot register type, whatever the type 2 is, because it's abstract. Otherwise, we'll let the code execution continue to register it as normal. So really the only change we've made is grabbing the type info and checking if it's abstract. So now we can go back to our test class and rerun this. And now we can see that our test case passes correctly. So the point of that demonstration was to really get you to think about, as you're writing tests, you really need to think about all the different requirements that you need to meet when you're designing new code. So there's going to be all sorts of unexpected scenarios. There's also going to be expected scenarios, and you should account for those as much as possible in your tests. So the final step that we need to do is do a little bit of refactoring. So we're going to go to our IOC container, and we're going to document it. And really, we didn't do anything with dependency injection in this demonstration, but this IOC container will be expanded to support it. And just some simple documentation, nothing too fancy. Okay, so just some basic code documentation, nothing too fancy. And you could even document your tests if you want, but ideally tests should be self-documenting. You should be able to understand what it is testing for by the test name. So we could even go as far as renaming this register type method to register default parameterless type, or register type with default parameterless constructor. So you could be a little bit more elaborate in your the names of things. So again, just a very simple demonstration on test-driven development. What we did is we were able to use TDD to develop a very simple IOC container that has successful quality tests behind the code. So this will facilitate quality development. So we'll do more test-driven development videos down the road. So I hope you enjoyed this. Some additional resources before we go. These were the resources I found that were very helpful for test-driven development when I was learning it. Code Complete 2, it doesn't really talk about test-driven development specifically, but it talks about testing in general. You'll learn about the different types of tests. You'll learn about different testing practices, formal reviews, formal and informal reviews, code reviews, walkthroughs. There's a lot that it talks about in regards to testing during the software construction process. Highly recommended. And then there's two books, Test-Driven Development and Microsoft.NET. Pretty good book, although towards the end of the book I started to lose interest in the material. But again, very good read, highly recommended. And then Test-Driven Development by Kent Beck, also highly recommended. So again, thanks for watching this presentation. Let me know what you think down in the comments below. I will post the source code on my blog and post a link in the video description. Have a great Memorial Day weekend.